If we are not alone, who or what else is out there? Is anybody listening? In 2042 AD, powerful orbiting telescopes scour the heavens for signs of life. They focus on a dim yellow globe. Spectrum analyzer results: negative. No oxygen, no life. The auto tracker zooms into another world, a pale blue dot. Oxygen signal affirmative, and there appears to be water. This could be it. The scenario belongs to the future, but the future is almost here. Life on Earth may have begun with a bang, when microorganisms hitching a ride on a comet or asteroid crash-landed on our planet. Finding themselves in a mild and watery world, the single-celled organisms could have slowly evolved into the rich and varied life forms that exist today. There are clues that this may have been what happened. But what do these early microorganisms look like? And from which planets or moons might they have come? Single-celled organisms are just one example of life that might exist in the depths of space. There could also be intelligent life out there, way beyond our own solar system. Some people go as far as to say that aliens have already appeared on Earth, that governments have hidden them away in secret military establishments. Today, serious efforts are being made to search for life on other worlds. Radio telescopes listen for signals transmitted from civilizations at least as advanced as ours. Seth Shostak works for SETI, the search for extraterrestrial intelligence, the offshoot of an earlier NASA program.
People in the last century thought about possibly searching for aliens using lights and stuff like that, but in fact, radio searches began in this century, and really after the war. It was 1960 that the first really scientific radio search was conducted.
Invaders from Mars.
Popular fantasies about the appearance and intentions of alien beings are as varied as human imagination. Paul Davies is a physics professor and writer of popular science. He has studied the cultural presence of aliens in human history.
When most people think about intelligent alien beings, they have something very much like ourselves in mind, that they would look like us, think like us, and behave like us, but they'd be sort of super beings. And when you look back in history, stories of angels and giants and Greek gods and so on, they're always presented in this human or semi-human form. I think that's just some sort of deep cultural need to believe in something like ourselves, but better.
From a planet.
Humanoid aliens have been good business in the 20th century. B-movie makers in particular have found a winning formula in showing semi-human space creatures with a fanatical urge to conquer Earth.
I don't think it's very likely that the Earth has been visited by intelligent aliens. In fact, the whole business of travel from one star system to another, physical travel, I think is really rather fantastic. It's much easier to send messages and communicate with your friendly aliens next door than physically get in a spacecraft and go and visit.
We don't yet have the know-how to detect them, let alone travel to them if they exist. It's clear that only a technologically superior race could visit us. In the meantime, we strain to pick up unfamiliar radio signals and scan the heavens for clues. In almost 40 years, there have been only 4 possible messages, all of them false alarms. An alien signal heading for Earth could come from any direction. To speed up the search, a SETI program called Project Phoenix has made some choices.
Project Phoenix has a fairly straightforward philosophy. We point our telescope in the direction of nearby sun-like stars, stars that are cousins of our own sun. Those are the ones we think are most likely to have planets somewhat similar to Earth around them, and maybe with an advanced civilization on one of those planets.
No star in the search is farther away than 150 light years, and, like our sun, each one is over 3 billion years old. Plenty of time for intelligent life to have developed radio technology. The president of the SETI Institute, Frank Drake, pioneered the techniques used in the search for extraterrestrial intelligence. He doesn't rule out the idea that someone is tuned in to us.
The space around Earth is full of radio signals, and particularly television signals, which we have transmitted over roughly the last 50 years. In fact, there's a shell around the Earth, 50 light years in radius, full of our signals. And in that shell, there are about 1,500 stars which are now receiving our signals. And if anyone's there, they're able to find out all about us by watching our television.
Quick, quick, brand new, Richard Hudnut home, permanent, quick, quick, cut your winding time in half, takes half the effort, new crystal ocean does.
Can't SETI transmit powerful radio signals of its own, hoping for a response?
Some people think that Project Phoenix actually broadcasts inquiries into space and we wait for replies from the aliens. Well, we don't do that, and the reason is quite simple. Say that the nearest extraterrestrials were 100 light years away. Well, our question would take 100 years to get there, and if they deign to reply, it'll be another 100 years before their answer gets back to us. 200 years have gone by, you've probably lost interest, and surely your funding has gone away.
There may well be a communications technology that we don't know about yet, as we were unaware of radio waves only a century ago. Technology is definitely on the move. After a walk on our own moon, we began exploring new worlds by remote control using more and more advanced spacecraft. Among the most successful missions was Voyager 2. Launched in 1977, Voyager 2 explored the outer planets and their weird moons, moving ever deeper into space, into regions completely mysterious to us Earthlings. On board is a gold-coated phonograph record containing 116 images of Earth and its inhabitants, 90 minutes of music, and an audio essay of Earth sounds. The pace of technology has been so rapid that Voyager's computing capabilities are outdated, equal to just a fraction of a domestic PC. The computer subsystems on Voyager contain a total of only 33,000 words of memory storage. In 1976, the search for life and the exploration of the solar system continued with the Viking mission. Its destination, Mars. The mission, to land robot explorers on the Red Planet. On board were cameras and instruments designed to sample the Martian atmosphere and analyze the planet's dry soil for signs of life. But no life was found.
Well, as you can see
at NASA, Michael Meyer runs the administration's exobiology program, the search for life beyond Earth. For him, the Viking mission was not at all disappointing.
Viking was very successful in that it sent 2 spacecraft that landed on the surface, and part of their purpose was to measure whether or not there was life on Mars. And the experiment's very successful in that they went through, they did their measurements, and but the reactions that they found were not consistent with life.
But just because the Viking landers didn't conclusively find life on Mars doesn't mean life isn't there. It may nestle on the surface or underground. Mars, more than any other planet, has tantalized us with the notion of extraterrestrial life, intelligent or otherwise. Since Viking took the first pictures, one strange surface feature called the face on Mars has attracted much attention. Some believe it's an attempt by another civilization to contact us. The Martian craze really took off about 100 years ago. The Clark Telescope at the Lowell Observatory, Flagstaff, Arizona. This great instrument was used to produce some of the most famous drawings of the red planet. The artist was the observatory's founder, Percival Lowell. Lowell thought the aliens were trying to make the best use of available precious water supplies, building a network of canals to transfer water from the polar to the equatorial regions, a sort of planet-wide irrigation system. He wrote extensively about these ideas. A few yards from the building housing his beloved telescope, Lowell's tomb is a monument to Mars. His theories were at first embraced, then denounced. Lowell was ridiculed by the scientific world, but he never stopped believing in the Martian canals. Ironically, both the Lowell Observatory and life on Mars theories are legitimate and respected today.
He built up interest in Mars, although he was completely wrong about Mars, and everything he said about Mars practically was wrong. But he built up interest in the planet, which is carried over to this day, and so he was quite useful to the Mars exploration program.
Space exploration revealed Mars has little atmosphere and no liquid water on the surface, yet its terrain appears to have been sculpted by water. NASA geologist Ken Herkenhoff explains.
It appears that there were great oceans on Mars at some time in the past, and there's currently a debate raging as to exactly when these oceans occurred and how long they lasted, and whether there were ice sheets that flowed on Mars.
Today, the dry, cold Martian climate makes it inhospitable to life, but maybe not completely. An amazing survival story during the Apollo missions to our moon provided evidence that life can endure even harsher conditions. Two and a half years after the Surveyor 3 spacecraft was left on the moon, Apollo 12 astronauts returned, retrieved the lens of its TV camera, and with it, a collection of what seemed to be alien bacteria. But they turned out to be stowaways, bacteria from Earth that had traveled on Surveyor to the moon and survived there for nearly 3 years in an environment less hospitable than Mars. Here was the proof that life could endure, at least for a time, on a world other than our own. What other characteristics define life as we know it? What else should seekers of life on other moons or planets be looking for? Living things move and grow. Life needs to take in nutrients and eliminate waste. And there is one other quality that is perhaps the most important indicator of all. Oxford University biologist and author Richard Dawkins.
The most general characteristic has got to be reproduction, the property of heredity. Everything else follows from that. Once you've got anywhere in the universe heredity, the equivalent of DNA, it doesn't have to be DNA, but the equivalent of something that makes copies of itself, genes in other words, then Darwinian natural selection, evolution, and life will follow. Now, in practice, on this planet, life has all sorts of other properties like respiration and feeding and things like that. But the fundamental one is reproduction.
Today, our planet is a haven for life, a far cry from its violent beginning. The young Earth was radioactive, hot, volcanic, with no oxygen. The atmosphere was cloudy, full of noxious gases, carbon dioxide, ammonia, methane. red carpets of lava flowed over dark volcanic rock until water from the planet's interior formed the vast oceans where life first appeared. Understanding how life got going on our own planet will help us target where we look for it in space, both within the solar system and beyond. Biophysicist David Deamer studies tide pools. A tide pool has the right mix of conditions for the formation of the first simple organisms.
If we think about the kinds of key events that might have been part of the beginning of life, certainly one of them had to be a sufficiently concentrated solution. Life could not have begun in a highly dilute solution of molecules because they can't find each other. Molecules wander all over the place. The only way they can react is if they bump into one another. So this means that there must have been a concentrating mechanism. Tide pools are an obvious concentrating mechanism because as a tide pool dries out, everything in it gets more concentrated.
In his lab, Dr. Deamer wants to see how the first microorganism might have sprung up under similar conditions.
Imagine the tide has gone out and the pool is drying up and leaving behind a thin film of organic material. In this case,
simple organic material likely to have been on Earth before life began.
And the tide comes back in.
The incoming tide churns the matter together. Ultraviolet light, like the sun, adds a heat source. With the agitation and higher temperatures, something begins to happen. Some of the molecules have formed bubbles, and another kind of molecule has become trapped inside the bubbles, mimicking a cell and its nucleus. Although not actually a living thing, this simple structure mimics a single-celled organism that could have sprung up under similar conditions. Yellowstone Park. Like a reminder of early Earth, it has steaming lakes and hot mud pools that erupt at burning temperatures. A much less forgiving environment than a tide pool, yet here, against all expectations, life has taken hold. Some microorganisms are being fossilized as quickly as they form. Dr. Jack Farmer is one of NASA's exobiologists. If he can understand how simple life forms become fossilized here on Earth, space fossils may one day be easier to spot.
What I'm interested in an environment like this is how organisms are captured during the process of mineralization that occurs and turned into fossils. And the idea is that the rates at which these minerals are forming is so fast that the organisms don't even have a chance to die before they become entrapped in the minerals. And that means that you capture a lot of biological information, mostly as different types of fabrics in the rock. So this is a really excellent place to look for microbial fossil information.
The hot conditions at Yellowstone are almost like early Earth, but not quite. There's too much oxygen.
When life started on this planet, there wasn't any free oxygen in the atmosphere. There was obviously oxygen in the world, but it was bound oxygen. It wasn't free oxygen. So all the oxygen in the air has come from green plants, ultimately. When it first appeared, therefore, it would have been seen as a poison. It would have been a pollutant. But gradually, through Darwinian natural selection, living organisms have become more and more used to oxygen. They've been selected to thrive in the presence of oxygen, so that now most living organisms can't live without oxygen.
Green plants can trap the sun's energy to produce not just the oxygen we breathe, but the food that supports the entire animal kingdom. The other great life giver on Earth is water. Our water-rich world is an oasis for life. Earth's sister planet Venus may also once have had water, but soaring temperatures caused by a runaway greenhouse effect have made it a hostile environment to living things. Venus and Earth had roughly similar potential for developing into life-supporting planets, but only Earth succeeded. At Lulworth Cove in England, Ellen Stofan is trying to figure out why.
This rock is Jurassic limestone that was formed over about 100 million years ago in shallow seas. This rock is made mostly of carbonates. It has a lot of carbon dioxide in it. On Venus, most of the carbon dioxide is actually in the atmosphere. On Earth, it's tied up in limestones like these that were formed in the Jurassic. Why did Venus end up with all its carbon dioxide in the atmosphere and Earth with it tied up in big rocks like this is a question that we're puzzling with right now. We think it might have to do with something with the evolution of life on Earth. Maybe the Earth was just far enough away from the sun that it was cool enough that allowed life to evolve, took that carbon dioxide out of the atmosphere. On Venus, all the carbon dioxide remained in the atmosphere, and we ended up with a planet that's baking in its own heat.
When the sun sets, Venus is often the brightest object in the sky, outshining the night lights of Tucson, Arizona. It twinkles like a star because the planet's dense cloud cover is extremely reflective. In 1967, Venera 4 became the first space probe to penetrate the Venusian clouds and transmit data. The first probe to soft land on the surface and send back information was Venera 7 in December 1970. The Venera landers only transmitted data for about an hour before being destroyed by the planet's intense heat and pressure. In August 1990, the Magellan mission began a radar survey of Venus, which allowed imaging experts at the Jet Propulsion Lab to create this simulation of the Venusian landscape. No traces of life were found, but scientists were delighted to become more closely acquainted with our neighbor planet.
Looking at Venus through a telescope, it's magical because, it is the evening or morning star, and, seeing it as a planet itself is kind of exciting. But at the same time, since it's totally covered by a set of dense clouds, one would like to see more. And so with Magellan, we got the first chance, one of the first chances, to really get a complete map and view of it.
The Venusian landscape has a desert-like appearance, but it's a good deal hotter than any desert on Earth.
On Venus, it's about 500 degrees centigrade due to that greenhouse effect, so it's far too hot for life to exist. In fact, we think that greenhouse has existed for a very, very long time, so that even if we could get samples back from Venus, we don't think we'd find any fossil evidence of life. Here on Earth, there was abundant water, and that's where life began.
Temperatures and pressures on parts of our own ocean floor are similar to those on Venus. Not especially hospitable, in fact, downright hostile. Yet, even in these conditions where there is no oxygen, life flourishes around smoking hydrothermal vents. All over the Earth, there are amazing examples of life surviving, even thriving in harsh environments. These hardy life forms on Earth add power to the argument that life may once have existed, may still exist, in forbidding environments elsewhere in the solar system. The first humans to land on Mars may yet discover the imprint of life.
We don't know that life originated on Earth. It could have come here from elsewhere in a meteorite or comet or something. Now, from time to time, asteroids and comets hit Mars and splash Martian material around the solar system. And we know that some of this material comes to Earth because there are about a dozen meteorites that have been identified that come from Mars. One of these meteorites could have brought life here to Earth.
This is no ordinary rock. It was found on Earth, but it came from Mars, one of at least a dozen alien rocks from the Red Planet. 13,000 years ago, a rock fell to Earth. In 1984, it was found in Antarctica at a place called Allen Hills. For over a decade, this Mars meteorite stayed at NASA's Johnson Space Center. It had been mistaken for a piece of the moon. But in 1996, NASA scientists took a second look. Inside the meteorite, there appeared to be microscopic fossils, possible signs of life. The meteorite made front-page news around the world. But the initial euphoria was replaced by doubt when the evidence proved to be inconclusive.
The Allen Hills meteorite is a very important find. The things that we do know for sure is that this meteorite is very old. It's one of the oldest objects in the solar system. It had fractures that were filled with carbonates precipitated from environments perhaps not unlike this one. I mean, we think perhaps they were hydrothermal.
Even if the Allen Hills meteorite shows evidence of possible microscopic fossils, this is still not proof of life on Mars.
So really where we rest on the Allen Hills meteorite is that it's an important find, but not indicative of biology.
What a time to be alive. In the last year, we've discovered planets around nearby stars. And today,
NASA Administrator Dan Golden accepts that the search for life on Mars is not over.
If we want to find out what Mars is like, what its weather patterns are like, what its geology is like, where there's potential sources of water and other resources, can we generate the substance of life, breathing gases, water, nutrition on the surface, you must send spacecraft.
In 1996, NASA launched Mars Pathfinder on a 7-month journey to Mars. 20 years had passed since the first Mars landing. Pathfinder has been designed to test a variety of new technologies for 21st century space exploration. The most challenging aspect of the mission is the landing on the Martian surface. Instead of fuel-guzzling braking engines, Pathfinder uses the planet's own atmosphere to slow it down from 17,000 miles per hour to around 1,000 miles per hour. A parachute slows the vehicle further to about 135 miles per hour. Seconds before impact, computers trigger the firing of small solid rockets and the inflation of a giant collection of airbags to soften the impact, which takes place at about 40 miles per hour. In the light of a Martian day, a solar-powered robot explorer roams an ancient floodplain, collecting samples in the continued search for past or present life.
When we go to a place like Mars and we ask the question, you know, if we were going to look for evidence of an ancient biosphere on Mars, where would we go to look? Well, it would be an environment like this. So by studying these places and understanding the processes by which this biological information is captured, we're in a much better position to address those issues on Mars. We know first of all, what kind of targets to look for, so that when we send landed missions there, we'll know where to go. Secondly, we know better how to interpret the information contained in those rocks when we bring samples back from Mars. So this is really a good training ground, really, for sample return missions for Mars.
If Mars has ancient salt deposits, scientists might be able to revive some sleeping Martians. Bolby Salt Mine in the north of England provides an example of how it might work. Microbiologist William Grant is about to tour a saline cemetery for microorganisms. Bolby Mine is all that remains of an ancient lake. It's one of the deepest mines in the world, also one of the hottest.
I'm about a mile below the surface and it's baking hot. I'm standing in part of what 260 million years ago used to be a vast salt lake, a bit like the Dead Sea or the Great Salt Lake, but much, much bigger. And 260 million years ago, this lake teemed with life.
Professor Grant seeks to revive dormant microbial life that might exist in the mine's salt deposits. He wears gloves and cleans his tools with alcohol to avoid contaminating the ancient salt samples with modern microorganisms.
The salt round about us was crystallized out 260 million years ago, and 260 million years ago, organisms in the salt lake contributed towards the crystallization, and they became incorporated in the salt. We've taken samples of this salt back to the laboratory, and we carefully dissolve away the mineral part of the material, and we feed the sample with nutrients that we know encourage the growth of these special bacteria. And indeed, from some of the samples, we were able to hatch out viable bacteria that might be 260 million years old.
If ancient bacteria can be revived on Earth, this may also be possible on Mars.
Mars, many millions of years ago, had water, lakes, rivers, and presumably salt lakes. And perhaps on Mars, the salt lakes harbored populations of creatures like the ones on Earth. So if one is going to look for life on Mars, and our earthly experience down here is anything to go by, where better to look for life than salt deposits on Mars?
The more examples of life surviving in a dormant state in harsh earthly environments, the better chance of finding it on Mars. Life has a way of hanging on, from the heat of an ancient salt deposit to the freezing cold of Antarctica. A lone scientist stalks the vast plains of the southern continent. Professor E. Emery Friedman is looking for rocks that hold some of the hardiest microbes on Earth. It's not as cold as Mars here, but almost. In his giant freezer at the Florida State University in Tallahassee, Professor Friedman keeps over 300 samples of bacteria found in rocks around the world. The bacteria are removed from rock in his laboratory.
We collected this rock in the Antarctic desert, and this is a rock which is colonized by microorganisms. The surface is lifeless, but under the surface, here, microorganisms exist, which can be seen in this black zone and the leached white zone. The surface of the rock is also to isolate the microorganisms in this laboratory and grow them. We'll transfer pieces into sterile medium.
One day, we may isolate sleeping Martians in a similar way.
I'm putting this enrichment culture here into light because these microorganisms, like plants, need sunlight. This is a rock which has been placed here about 2 months ago.
Here are the bacteria that have thrived in some of the toughest cold conditions that Earth has to offer. Professor Friedman believes these rugged microorganisms are probably capable of surviving on Mars. Mars is certainly our best bet for finding life in the inner solar system. But the chances of life existing in the outer solar system have never been more promising than at present. Jupiter, Saturn, Uranus, and Neptune are the gas planets of the outer solar system. In Massachusetts at MIT, Heidi Hamel has investigated the unforgiving environments of the gas giants. She is not optimistic about finding life on the planets themselves.
Even though those planets do get somewhat warm deep inside them, at the pressures and temperatures of the outermost clouds, they're just too cold. They're too cold, and it's too dark. There's just not enough sunlight there. There's no liquid water, and that's what we'd need to sustain life. So it's not likely.
Artists and science fiction writers may imagine that there are weird jellyfish floating around Jupiter, but it's most unlikely. Freezing Pluto, on the other hand, is a world of rock and ice, not a ball of gas like the 4 giant planets. The outermost planet, Pluto, is certainly too cold and dark to be a serious candidate for finding life. There are nearly 60 moons in the outer solar system. Research so far shows that most of them are inhospitable to life as we know it, but there are 2 exceptions. One is Titan, Saturn's largest moon. In November 2004, the Huygens probe will parachute through the clouds of Titan. It could splash down in a bitterly cold ocean, or a lake of liquid hydrocarbons, or even on a solid surface. Titan is like a frozen early Earth. It has many substances that were around on Earth before life began. The Huygens probe will explore whether Titan has the potential to spring to life.
The organic chemistry in the atmosphere of Titan is particularly interesting and may provide us some real interesting insights into the nature of prebiotic chemistry. It may have also produced life. We just don't know.
In the future, Titan could look like this. When our sun expands to 50 times its present size, 5 billion years from now, Titan will receive as much energy as Earth does today. For a short time, it might well become a blue ocean world where life thrives. In the meantime, Jupiter's rocky moon, Europa, is the most exciting candidate for finding life in the outer solar system. In 1996, the Galileo spacecraft returned the most exciting evidence yet that Europa has oceans. Oceans that could teem with life. Galileo's images revealed areas where ice fragments have broken and moved apart like pieces of a jigsaw puzzle. The cracks suggest that the ice is shifting on a dynamic surface.
We have reasons to suspect, based on recent high-resolution photography of the surface, that there may be a subsurface ocean there. And where we find water and where we find the right mix of organics, there's the possibility for life. So we have to entertain the idea then that Europa could provide in this subsurface ocean environment a habitat that would be clement for life and where life could have originated.
I don't know whether we'll find life beyond single cell. And when I talk about life, I want to be very, very clear. Single cell life would be an unbelievable find. And any higher level, I just don't know. I just don't know. But I doubt that we'd find a human species.
When our spacecraft eventually penetrate Europa's icy sheets, they might find scenes like this. An undersea world where life prospers without sunlight or oxygen, like our own deep ocean thermal vents. And beyond our own solar system, there's always the seductive possibility that an intelligent group of beings like ourselves exists somewhere. After all, our sun is one of billions of stars that shine in the universe, a universe that contains all the elements found in life on Earth. A distant star could be the sun of another civilization. Could aliens have paid us a visit already, maybe eons ago?
It's always possible that there is something we haven't recognized that has been left here maybe a long time ago by an alien visitation. But in the absence of presenting me with that evidence, I see no reason to believe this. I really think it's such an expensive exercise to physically travel from one star system to another. I can't imagine the motivation of any alien species that would do it.
Humankind has explored the solar system, but we lack the technology to send manned or robotic missions to another planetary system. But we've certainly left evidence of our own existence. The trail of debris from our space missions, like Hansel and Gretel's breadcrumbs in the forest, may one day mark the way for an alien group looking for us.
Life probably does exist elsewhere in the universe, but probably not sufficiently frequently in the universe for us ever to be likely to meet it. So that would be my guess, is that life is present elsewhere in the universe, but is probably so spaced out that we may never know about it.
Out there, way out there, in other galaxies. What is the likelihood? The president of the SETI Institute has developed a complicated equation to actually figure the odds. It's called the Drake equation. It's based upon things we do know about the universe and other things we can make educated guesses about. Things like how often new stars form, how many stars have planets, how many planets have life, the chance of that life developing intelligence, the chances that intelligence will lead to technology, how likely that technology will destroy those who invented it. The Drake equation doesn't exactly narrow the field. Depending on the variables, the number of intelligent civilizations could be 0, or 1 billion, or any number in between. Richard Dawkins thinks the last factor in the equation might explain why the heavens are so silent.
It's been rather pessimistically suggested that when a civilization anywhere in the universe becomes advanced enough to, say, develop radio telescopes or the ability to communicate by radio over vast distances, that level of technology almost inevitably is close to destroying itself by atom bombs or similar weapons of mass destruction. Now, if this is true, it could be an answer to the question, why haven't we heard from other forms of life?
It's also possible that an intelligent civilization might have more in common with our machines than ourselves.
A really advanced civilization might have gone beyond biology to develop machine intelligence. Machine intelligence could spread throughout the galaxy a lot more easily than biology could. So it may be that if we pick up a signal, it's not from biology at all, it's from a machine, a thinking machine.
If thinking machines populate another world, they may have evolved not from carbon molecules as we did, but from silicon, the same kind of silicon that's the basis of computer technology. Silicon is not all that different to carbon.
Just possibly you could imagine a kind of fantasy science fiction life which was not carbon-based but silicon-based. But you don't have to go to silicon. You could have other kinds of carbon-based organic life which would be very, very different from life on this planet as we know it and still be living.
To stand a chance of supporting carbon-based life, there must be water. Water is essential to life as we know it. We have no evidence that life could exist on another moon or planet without water. As new moons and planets are discovered, there are bursts of hope that some life other than life familiar to us is out there. 1995 saw great excitement when a brand new planet was detected. 2 Swiss astronomers spotted the planet beyond our own solar system. For the first time, a planet had been found orbiting another star. Within a year of this discovery, more new planets were announced. This time, the glory belonged to 2 American astronomers using the Lick telescope in San Francisco. It was this great instrument that caught the light from a distant star and showed the world that planetary systems may be common. The planet finders were Jeff Marcy and Paul Butler, and no one was as surprised about it as they were.
When Jeff first suggested that we might find planets, it seemed like an outrageous idea, but still, it was, a lot more exciting than most anything else I could imagine. So I jumped at the chance to look for planets. I didn't know if it would ever work, and it's been a long, long struggle to get here.
Garbage. Well, the way we look for planets is actually very easy. We can't see the planets orbiting other stars because the glare of the star is just simply too great. It wipes out the planet's light. But what we can do is look for the response of the star due to the gravitational pull by the orbiting planet. And so we watch to see if the stars wobble in space, and if they do wobble, we can infer the presence of the planet.
The work involved in discovering new planets is a real grind.
I wanted to give up several times. In fact, I've thought carefully about suicide even occasionally when things were so dismal. But the success now makes up for all of it. This is one that we had previously discovered. It's the star 47 Ursa Majoris. And these data show the wobble of the star just within the last year. And this last point we just got last night. And you can see it fits right in line with all the other points. So this is a confirmed planet around 47 Ursa Majoris.
And it's a good thing it's confirmed because we've already announced that we would have to kill ourselves.
Without their unique working relationship, Marcy and Butler doubt whether they would have achieved their current success.
Beautiful. Well, my working relationship with Paul Butler is really quite special. He brings attributes to this project that I certainly couldn't have brought, and vice versa, I believe. And we have a sort of symbiosis going in which we work together, we each make up for each other's failures, and because of that we have an excellent sort of dovetailed working relationship.
We have very different styles and we complement each other very nicely. Jeff is very methodical and he wants to absolutely understand every step, and he forces me to go back and really work hard, and I just like to just dive forward. You know, if there's some problem I just like to attack it 20 different ways until something works. So it's a good collaboration.
Marcy and Butler's double act goes on. They're constantly on the lookout for wobbles in the heavens, new planets that might, upon closer inspection, cradle life. Most of the planets discovered to date are similar distances from their stars as Mercury, Venus, Earth, and Mars are from the Sun, but they are much more massive. They're at least the size of Jupiter, some much bigger. Gas giants with powerful gravity. However, unlike Jupiter, we haven't a clue what they look like. Detecting new planets is one thing. Getting snapshots of them is quite another. In fact, some astronomers think that the new planets can't truly be verified until they are imaged. On Earth, scientists are building giant mirrors to construct the super ground-based telescopes of the future. Telescopes will lead the search for snapshots of distant planets. Most astronomers believe the best images of new planets will come not from Earth, but from the skies, from a new generation of space telescopes. Astronomer and Hubble expert Chris Burrows.
All of the new planets that people have found have been inferred indirectly. There have been no pictures of a new planet. But I'm very hopeful that in the next 10 years, we're going to get pictures of planets around other stars, direct pictures. And of course, with a picture, you can tell so much more. You can start to see perhaps what the planet's made of, and you can follow it in its orbits. You can understand it in much more detail.
In the future, the revamped Hubble Space Telescope may even detect planetary systems more like our own. Telescopes yet to be invented may one day confirm that we are not alone in the universe.
It is conceivable within the next 10 to 15 years that we could directly detect these Earth-sized planets that could have atmospheres, they could have oceans, we don't know. And we might also be able to sense their atmospheres from Earth with telescopes to see if there's water, carbon dioxide, and oxygen. And if we find carbon dioxide and oxygen, where the oxygen is in much greater abundance than the carbon dioxide, we will then speculate that photosynthesis takes place. That's the process on Earth where trees and leaves convert carbon dioxide to oxygen, and then we could really begin to think there could be life. But right now, we don't even know if there's an Earth-sized planet around the star other than our own.
Future generations might witness scenes like these from an alien world. The discovery of an Earth-like planet is a real possibility.
There's no question that having discovered planets tremendously enhances our interest and the prospects of discovering intelligent life in the galaxy. And the reason is, up until a few years ago, we didn't know there were any planets around any other stars. We might have been the only thing going in our galaxy.
Today, Earth is still the only place where we know for sure that life exists. Humankind has the only intelligent civilization that we know about. But there could be life out there. The mounting evidence motivates scientists to keep searching.
Are we alone? I rather doubt it. If we are, that would be almost more fascinating to me. And so I'm eager to continue the search, and even if it's the lowly microbe that we find as our cohort in the cosmos, I'll be satisfied.
Perhaps these are the fingerprints of a simple life form. Perhaps not. Mars holds out the most hope in the solar system, but then there are more than 100 billion stars in our galaxy, and there are countless galaxies. If it could be shown beyond doubt that life evolved somewhere, anywhere other than our own home planet, then life on Earth would never be the same again.